Okay guys, today we're going to be taking a look at more properties of line segments. Today our goal is to find the length of a line segment if I know the endpoints. So we've done midpoint, now we're taking a look at the length. So in this first question we're going to draw the line segment with endpoints 2, 1, a point at 2, 1, and a point at 4, 6. And we want to try and find the length of that line. So what we're going to do to try and do that is we're going to draw a right angle triangle here. So I'm going to draw a line here and a line here to create our right angle triangle. And actually I'll just label these points. So this is the point A, which is 2, 1. And my point at the top is the point 4, 6. And if I take a look at the sides of my right angle triangle, this bottom side is 2 units, and the vertical side here is 1, 2, 3, 4, 5 units. So the horizontal side is 2 units, the vertical side is 5 units. So now I'm going to use Pythagorean theorem to find the length of side AB there. And so to find the length of AB, it's the hypotenuse, so AB squared is equal to 2 squared plus 5 squared. And if I go ahead and calculate this, I end up with the square root of 29. So I add the 24 or the 25 and 4 together, and then I need to know what the AB is equal to. So AB, because it's squared, the squared goes to the other side and takes the square root. And if we wanted to round that off to 1 decimal place, we get 5.4. Now, we could figure that out on the graph. How is that working with the coordinates of the points, though? So if you notice the coordinates of the points here, if we take a look at the 2 x values here, the 4 and the 2, how do the 4 and the 2 end up giving us a horizontal distance of 2? Well, if we subtract those 2 values, 4 minus 2, that gives us the 2. Let's see if that works for the y values. If I do 6 and I subtract 1, that gives me 5, and that is the vertical distance in my triangle up above. So to find the length of the horizontal side in this situation, we are taking x2 and subtracting x1. And when we subtract x2 and x1, we get 2. And for the vertical side, if we do y2 minus y1, we get the 5. So let's try and tie these two concepts together. The idea of Pythagorean theorem and these expressions we've just come up with for horizontal side and vertical side. So we know from up above here that AB squared is equal to the horizontal side squared plus the vertical side squared. But we just came up with expressions for each of these here. So we can actually write that AB squared equals, and this is x2 minus x1 is the horizontal side, and y2 minus y1 is the vertical side. Now, ideally, we don't want to know what AB squared is. We want to know what AB is. So if I take that square to the other side, it changes to square root. And when we do that, we end up with the formula for finding the length of a line segment when we know the two endpoints. So we're going to use this in some examples here. So find the length of the line segment with endpoints -6,5 and 4,3 by both graphing and by using the formula. So we'll do the graph first here. So -6,5 is this point here, that's B. And C is 4, -3, that's this point here, that's C. So I'm trying to find the length of this line right here. Okay, so I'm trying to find the length of that line. So remember, using the graph, I'm going to use my vertical distance and my horizontal distance. So the distance across the bottom here is 10. The distance going up the side is 8. So if I do it by Pythagorean theorem, it's going to look like this. Well, I'll write Pythagorean theorem is a squared plus b squared equals c squared. We're trying to find the length of the hypotenuse, so my other two sides are the 8 and 10. So I have 64 plus 100 equals c squared. So to figure out what c is, we take the square root of 164. We end up with 12.8 if we want to round that to one decimal place. Okay, so that's what we get for c that way. Now, if we try and find it using the formula, so for the formula, I'm trying to find the length of BC. So using our formula, remember it's x2 minus, x2 minus x1 squared plus y2 minus y1 squared. Sorry, it's a little bit of a mess here. And then we can plug things in. So using our points from up above, let me just get rid of that guy for a second. Using my points from up above, my two x values, and sometimes what I'll, it might be easier for you guys if you actually write these points one over the other like that, so the numbers are organized the way they should be. So when I subtract the x's here, it's going to be -6 subtract 4 squared plus, and then when I subtract the y's in the same order, so I'd have to start with the 5, and if it's 5 subtract -3, it's going to be 5 plus 3. So then I clean things up here. This is going to be -10 squared plus 8 squared. And what I'm going to end up with is 164. So BC is equal to 12.8, whether we use the formula or Pythagorean theorem there. So let's use the formula then to do these questions. So in the first one here, I'm finding the length of AB. I'm going to subtract the x's, so -2 subtract 5 squared. Then I'm going to subtract the y's in the same order, 4 minus 7 squared. So I'm going to end up with -7 squared plus -3 squared. So I end up with 49 plus 9. So AB is equal to root 58. Or if I round that to one decimal place, it's going to be 7.6 units. And over here, if I do the same for CD, so I'm going to subtract the x's, 5 minus 7 squared, and I subtract the y's, 0 subtract -11, so 0 plus 11. So I end up with -2 squared plus 11 squared. So I end up with 4 plus 121. So for CD, we get the square root of 125. Or if we want to write that as a decimal, it's going to be 11.2. So you can see how we use the formula there. Now let's look at the last example here. So in this example, a triangle has vertices A, B, and C. Is it equilateral, isosceles, or scalene? So it's important that we remember that if it's equilateral, three sides are going to be equal in length. If it's isosceles, then two sides are equal. And if it's scalene, no sides are equal. Now, let me just sketch a rough picture of what this looks like. And this doesn't have to be a perfect graph. We just want to get a picture of what it's going to look like. So if I draw a graph here, and the first point's 5, 7. So if I figure 5, 7 might be about there. So I'll call that A. Point B is 6, negative 11. So a little bit further to the right and down a little bit lower. So that would be B. And then C is negative 8, 4. So negative 8, 4, we'll say, is over in this area right here. Okay? And then if we join those guys, now it's hard to tell from this sketch whether it's equilateral, isosceles, or scalene. So what we need to do is find the length of each of these sides. So I'm going to plug those into the formula and we'll pick up where when I get to that point. Okay guys, so you can see I found the length of each side using the formula. The big thing when you're using the formula is you really have to watch your negative signs and when you're subtracting. So just be careful that you take your time on those and you don't rush through them. So you can see, looking at our situation here, that the side lengths are not equal to each other at all. And in this case, I just left them as square roots. We didn't need to find the length to one decimal place or anything. Sometimes they will ask for that. Other times you can just leave it as square root. So to answer our question then, therefore, since all sides are different lengths, the triangle is scaling. Okay, great. So we'll practice some of these tomorrow in class.